My name is Coffee Alexander. I did my project on honeycombs. A honeycomb is a mass of hexagonal prismatic wax cells built by honeybees in their nests to contain their larvae. It also stores honey and pollen. Beekeepers remove honeycombs in order to harvest honey. One example of math in honeycombs are that honeybees need to consume 8 kilograms of honey in order to make 1 kilogram of wax. This is an example of mass simply because to calculate kilograms, grams, milligrams, and other forms of mass numbers are used. A kilogram based on the prefix kilo means 1,000. Therefore, it takes 8,000 grams in order to make 1,000 grams of wax. The second way I found math to be involved in honeycombs are that honeycombs use a 3D hexagons that meet at each polyhedron vertex. A polyhedron is a solid figure that has usually more than 6 plane faces. Another way math is involved in honeycombs is because a honeycomb begins as the shape of a circle and then morphs into the shape of a hexagon. A circle is a two-dimensional shape made by drawing a curve that is always the same distance from a center. A hexagon is just a polygon with 6 sides. A Greek mathematician named Zindoros discovered that regular polygons enclose the greatest area. These regular polygons include equilateral triangle, which is a 2D shape where the sides have equal length and the angles are all 60 degrees to accommodate for the equal length. The other regular polygon is a square. A square is a flat shape with 4 sides of equal length and where all the angles are equal to 90 degrees. The final regular polygon, according to Zindoros, are regular hexagons. The only difference between a regular and an irregular hexagon is that a regular hexagon has all equal sides, while an irregular hexagon has all unequal sides. While doing my research, I found 2 new things about math. This includes what both an end radius and a circumradius are. An end radius of a polygon is the radius of its end circle, which is inside the polygon. The circumradius of a polygon is the radius of the circle outside where the polygon can be inscribed, or in other words, around the polygon. Both the end radius and the circumradius are represented by an r. However, an end radius is represented by lowercase r and a circumradius is represented by a capital R. In the formula for finding both circumradius and end radius, a represents the number of sides that can be found with the side length represented by where n equals 6. In the case of a hexagon, the lowercase r, which is end radius, is found in the formula 1/2 a cotangent pi over 6 equals 1/2 radical 3a. The uppercase r, which is represented by the circumradius, is the formula 1/2 a cosecant pi over 6 equals a. The other piece of math that was found during research involving hexagons was the area of a hexagon, which is equal to 3 rad 3 over 2 times a squared, where a is side length. The perimeter of a hexagon is found by p equals 6a, where a is also equal to side length. The reason my mathematical topic follows the pattern of packing hexagons together is because if you pack them together, they have identical shapes all together in order for them to fit. It also follows the pattern because a hexagon uses the least amount of building material to hold the most weight. I use a hexagonal pattern because they are easier to tighten and loosen due to its 6 sides. Hexagons are used throughout evolution because of its simplicity, strength, and durability. Some of the research titles that I use include Polyhedron Vertex, Why Are Honeycomb Cells Hexagonal? What is a tessellation? Why do honeybees make hexagons? Why nature prefers hexagons? Why are hexagon nuts and bolts hexagons? How bees teach us the most scientifically efficient way to pack things, and the meaning of shapes and how to use them creatively in your designs.